In this short video, we're going to complete our discussion of levers and look at the physical manifestation of why humans have a particular type of lever designed for their extremities. And so when we think about human biomechanics, most human parts, if you will, particularly our extremities, are designed as third-class levers. And essentially here, when we talk about a third-class lever, that in order to move a load of particular mass or weight, we have to proportionately apply greater muscle force to move that load if we're talking about a third-class lever. And that highlights the difference between two concepts called mechanical advantage versus speed advantage. Mechanical advantage refers to the ratio of the moment arm, and recall that a moment arm is a distance measurement, a perpendicular distance from an applied force to the point of rotation. And so the mechanical advantage is the ratio of the moment arm of some force to the moment arm of the load or the weight of that lever. And if a lever is in a position of mechanical advantage, the ratio of these moment arms are going to be greater than 1. Human extremities, however, are designed to have a ratio of less than 1, so to be in a position of mechanical disadvantage. And what that affords human extremities is to have what's called a speed advantage, which is the opposite to having a mechanical advantage. And we're going to illustrate that here with this example of a person that will try to flex their elbow and move a load in the hand. So in this example here on the left hand side, here we see that the person's arm and the mass that they're holding, their forearm and the mass, can be concentrated with a weight located at the center of mass, which is approximately the halfway distance between the elbow and the distal portion of the forearm and hand. And we would draw that with a vector applied at the center of mass, directed vertically downward. Now, to cause the elbow to actually rotate and to flex, here we know that the elbow flexor muscle group, in this case this is an illustration of the biceps brachii muscle, which has a point of attachment at what's called the radial tuberosity, and when it contracts it pulls towards the center of the muscle, and that we clearly see that the fulcrum, which is the elbow, is positioned on one side from both forces. Now these two dots represent the degree of shortening of the muscle. So if this muscle pulls the point of attachment just this small distance, just this little bit of distance here with muscle shortening, we see that the final position of the arm is illustrated with this representation of the forearm and the hand. So what we see here is that the muscle will have to produce a force much greater than the weight of the forearm, but by virtue of the fact that it's a third-class lever. But what this gives the forearm and hand is a wide degree of motion, and that's what allows humans to be functional with respect to extremities. Now, on the example on the right-hand side, if we took this muscle and surgically changed it where the points of attachment are a little bit more distal along the humerus, and on the opposite side of the weight of the forearm and hand, once again centered here at the center of mass with the fulcrum at the elbow, and we shorten that to the same distance. So the purple line here represents the degree to which the arm, the degree to which the muscle is shortened by the same length that we see here on the right hand side, then the amount of motion would be much less. So what we see here, if we had redesigned the elbow as a second class lever, and as a second class lever the applied force is on the opposite side of the weight vector, opposite than what we saw over here with the third class lever from the fulcrum, that the muscle would be in a position of producing, actually it would have to produce less force to counteract this weight, where on the left hand side this muscle would have to produce much greater force to counteract this weight. But by producing greater force, the position of the force vector for the muscle is such that it allows a much greater range of motion, but where we gain mechanical advantage, we lose speed advantage because the distal part of the extremity would only move a very short distance. So this ends our coverage here of second and third class